All right, today we're going to talk about solving two-step equations. These are relatively simple. So as we look at this one, we got 2.5x minus 13 equals 2. As I begin solving it, first thing I'm going to do is write in that equation. I'm now going to be looking at what things are happening to the x. So I've got multiplying by 2.5. I've also got this minus 13. Now that's what I'm going to start with. I'm going to start with adding 13. If we wanted to start dividing by 2.5, that is a possibility, but keep in mind that if you do that, if you decide to divide by 2.5 to begin with, you're going to be dividing everything, even that 13, which means you're going to be creating fractions which you may or may not even want to be dealing with. Okay, so now that we've got this, negative 13 plus 13 is a 0. 2.5x minus 0 is just 2.5x. And then 2 plus 13 is 15. All right, so now at this point, we've got 2.5 times x. We are going to divide each side by 2.5 because that's what we were multiplying by. So divide by 2.5. Divide by 2.5, and that is, when we do 2.5 over 2.5, that's 1, so we have 1x is going to be equal to 6. All right, so now that we've got our answer and we know x is a 6, in order to check our answer, we come over here, we start rewriting the equation just as it was, the main difference being that in place of the x, we put that 6. All right, so 2.5 times 6 equals a 15. 15 minus 13 is 2. 2 does equal 2, so we definitely found the right answer. All right, now we've got a new problem here. In this problem, you'll notice one thing that's different is we have got those two f's over there. All right, so in order to do this, since they are on the same side right now, the same side of our equals line, that means we can combine them. They are like terms. This is going to be a very common first step. So we got this 5f plus 4f equals 9f minus 8. If two terms have the same variable, or if two terms just don't have any variable, then those are situations in which you can add those together and combine them. So now that we've simplified it using combining, it now looks a lot like the last problem. I'm minusing an 8, so I will add 8 to each side. After I do that, 19 plus 8 equals 27. Negative 8 plus 8 is a 0. 9f minus that 0 is just going to be 9f. Now we got 9f is equal to 27. Divide both sides by the 9 that we were multiplying by. 9 divided by 9 is 1. So we have 1 times f is f. 27 divided by 9 is 3. So we say that f is 3. Let's put it back into our equation to test this out. 5 times 3 plus 4 times 3 minus 8 equals 19. 5 times 3 is 15 plus 4 times 3 is 12 minus 8 equals 19. 15 plus 12 is 27. 27 minus 8 is 19. So yes, that definitely works out. We have found the right answer. For this next example, I'm actually going to solve it two different ways. Both the top and the bottom are exactly the same equation, but just because they're the same equation doesn't mean there's only one approach that we can take to this. One of the great skills of a mathematician is being able to look at a problem, recognize the different ways to approach it and picking the one that's going to be easiest. Okay? And that's what we would really want to go for, is making our life easier. Okay, so for this first one, we're going to remember how to do distributive property. 4 times the n times 4 times the 6. So we would then get 4n, and then 4 times negative 6, negative 24 minus 1 equals 31. So there's our distributive property. We can also, at this point, combine those like terms. So we'll have 4n, and negative 24 minus a 1 is a negative 25. So minus 25. Now that we've got that, it's starting to look a lot like equations we've dealt with before. Because we're subtracting 25, we will add 25 to each side. And once we've done that, negative 25 plus 25 is 0. 4n minus that 0 is just 4n. 31 plus 25 is a 56. Now that we've got 4 times n, we divide by the 4 because we're multiplying n by 4. So then 4 over 4 is 1. 1 times n is n. 56 divided by 4 equals 14. All right, so now we've seen how to find that one by using distributive property and then combining our like terms. This time, I'm not going to use distributive property. Sometimes the reason why you might want to avoid distributive property, this 4 was a nice, but what if it had been like 4/3 or some other fraction that as we look at multiplying it through, it wasn't going to simplify, which then would have meant when we subtracted this 1, we'd be subtracting 1 from some kind of difficult fraction. We can do these things, but we're really making our work even harder by choosing to go that route. So we can avoid distributive property altogether. This time, we're going to start off by just getting our parentheses alone. So we'll add 1 to each side. So that's going to be 0, leaving us only with the 4n, well, parentheses, n minus 6, equals 32. Now, because we are multiplying this whole thing right here by a 4, we can divide that whole thing by a 4. And if we do it to one side, we do it to the other. The benefit of this is because we multiplied it all by 4 and divided by a 4, and those are opposites, essentially what we've created is 1. 4 over 4 is 1. That's what it'll simplify into, so we'll have n minus 6 equals 8. We've still got that minus 6, so we'll do the opposite, plus 6 to each side, and we have n equals 14, same as above. Now, you can take multiple approaches when solving equations. It doesn't always have to be those exact same steps. What you need to keep in mind are some of the simple rules. Whatever I do to one side, I do to both sides. Actually perform the operation. Don't just try to think of numbers as disappearing. When I put 4 over 4, I don't think of it as 4 disappeared. It's 4 divided by 4 turned into 1. And then 1 times my variable, well, is just the variable, because anything times 1 is just itself. I'm using the math to transform the numbers, especially into either 1s or 0s, so that they easily can be ignored from the rest of the equation. All right, so here we've got a word problem. And they say we're going to use this table to find the high temperature X on Wednesday so that the mean high temperature for the 5 days is 65. So some key things to note. We're talking about mean. We're over 5 days, and we want that mean to equal 65. All right, so first, let's focus on how we calculate a mean. in order to calculate a mean, what you're always going to do is to add up all of your numbers first. So we've got 76 plus 70 plus our unknown temperature on Wednesday plus 68 plus 55. After you've added up all of your values, you divide by how many there were. 5. We were also told that the mean was 65, so that's what it's equal to. One of the first steps I would do here is to combine those like terms. We got a 76 plus a 70. We can do that. Plus 68, plus 55. So after I combine all of those like terms, I'm going to have 269 plus x over 5 equals a 65. Now, because usually I handle the plus and minuses first. However, if I try to subtract a 269 here right now, PEMDAS doesn't let me do that because PEMDAS says that division has to happen before that addition. So I can't access it right now with the way that it's written. Okay, because essentially it's operating like as if there were parentheses up top. That fraction says you need to do what's on the top first. So we're going to deal with that 5 first. And what we're going to do is multiply each side by a 5. As we multiply each side by 5, this side would give us 5 over 5, which is just 1, leaving us with 269 plus x equals 5 times 65 would be 325. And now we are going to get rid of that 269 by subtracting 269 from each side. All right, so as I do that, 269 minus 269 is a 0. There we've got our x. I'm probably not going to do that in my head, so I'm just going to give myself a little time to write that out. So 556. So high temperature on Wednesday was 56 degrees, and that's what gave us the mean high temperature of 65. Okay, so in this problem, we have you spent $50 on supplies for the bake sale. Each item sold for $2. After the sale, you had a profit of $180. So how many items did you sell? Let's focus first on the fact that we're talking about profit. So we should all know how profit is calculated. The way you get a profit is by taking your money in. Now there are different, more technical terms. I don't want to really get into all of that right now. We're just going to talk about the money you're bringing in from your sale. And we take that money and we subtract the money spent. How much it cost us to make everything that we were making. So profit is the money in, subtract the money out, or the money spent. So there's one thing that we don't know, and it's right there in our question: how many items? So our variable is going to be exactly that. It's going to be the number of items. All right, so here's going to be our equation. We've got the profit, which we know the profit was $180. As far as the money in goes, we know we sold each for $2, but $2 of how many, we don't know. So 2 times however many items we sold. If we sold five items, that means we brought in $10. If we sold 20 items, that would mean we brought in $40. So we just need to know what X is. Finally, take out the money spent, and that's $50. So there is our equation. First thing we're going to do to each side, add the 50 as we start getting x alone. Negative 50 plus 50 is equal to 0. 180 plus 50 is 230. So now that we've removed the money we spent from this equation, it looks like our money in was about $230. So we take our $230, divide it by $2 for each item, and that tells us we'd have $115, or 115 items. So we sold 115 items for $230, but we spent $50 in making it. That gave us our profit of 180. So that is our answer, 115.